Hi, everyone. I'm Clay with Claiborne LSAT. I've got a fascinating logic game for you today. I hope you'll pardon my enthusiasm. I do think this game is fascinating. It's got some unusual features. You'll know from clicking on the video that it is, it's test 24 and the last game, game 4. So let's go ahead and label that. As always, I'm not going to read out the text or post it here out of respect for copyright. So let's go right to it. You'll notice that this is an in-out game. If you're familiar with that concept, we have a total of 9 treatments and only 5 of them are chosen. So that kind of selection is characteristic of an in-out game. We have some that are in, some that are out. We can just go I or O, in and out, or check and X, whatever you prefer. And we'll need to consider scenarios always with 5 in and 4 out. Now, there's a couple of reasons why I find this game so fascinating. One is the subcategories, which you get sometimes. We have 3 groups of 3 here, the antibiotics, dietary, and physical therapies. But there's another reason. Like most in-out games, this set of rules is full of conditional rules, but they're interestingly phrased. And there's only one star player. That is only one overlap where a player is mentioned more than once. That makes it challenging to put these rules together. And the final reason it's fascinating, you'll see with the outcome, it's quite surprising what actually takes place here. Now, forgive me, I'm going to erase these and put them a little bit lower because I always forget in setting up this game to leave room for kind of a subheading of a column. Because here's what we're going to want to do. Even though there's only one overlapping player, that is F, that's mentioned in 2 rules, there are a couple of very helpful rules about the categories themselves, or what I like to call the labels. Do we label this a D or a P or an A? In particular, there's a very specific rule about the dietary that there's only one always prescribed. So I'm going to put a D at the top of this little sub-column. This first space, we're always going to have be a dietary. Now, take advantage of your out column as well. That's a mistake that's often made, is not taking enough advantage of the limitations of your out column. But it stands to reason that if we have one D in, we have to have 2 out. Now that's going to be huge as we go throughout this game. I'm going to note also the rule about the A's, that there can't be all 3 of them in. One of them has to be out, so we can go ahead and put an A right here. And notice that at least in terms of type or label or category, we've filled up 3 of the 4 out spaces already. So you want to use those labels or categories that a player belongs to very carefully and to its fullest extent. Now, with those preliminaries in place, we can start to look for that star player and begin to do what we do with conditional rules, which is the yes-no treatment. We look at the sufficient condition and we say, what if it is true? What if it's not true? And we test both of those options. I want to start with the star player, F, but I need F to be in the sufficient condition. So I'm going to contrapose both rules 3 and 4 to say if F is in, then we know 2 things. That O is also in and that W is not. So let's suppose for a moment that F is in. Now, F is not a dietary regimen, so we're not going to put it in the first space. But it causes O to be in, and O is a dietary regimen. If O is in, the other 2 Ds have to be out, M and N, and we're making some progress already. Now, this doesn't force any of the other rules to come into place, so you want to look for rules that are going to be productive for you, especially if you assume they're sufficient condition. I'm looking at the last rule, but we have to think carefully about how we translate the unless. Remember, you can replace unless with then, and then negate what becomes the sufficient condition. So we can rephrase the last rule as if V is prescribed, then H and M are prescribed. If V, then H and M also. Now, I actually misspoke a moment ago. I said that nothing was forced by this, but phrasing the rule that way helps us realize that something actually is forced here. If V being in causes H and M to be in also, well, we have M out. Remember we inferred that? If M is out, then V has to be also. Now, V is a physical therapy, so we're going to put it over here in our last spot, and we still need an A, an appetizer, to come in. Now, we've got one more rule to deal with, and that's the rule about G, N, and U. If both N and U are in, then G is out. So let's think about that one for a moment. It has to be both N and U. Then G is out. Therefore, if G is in, then one of them is going to be out. N or U. Well, that rule seems to be already accomplished because we have G, if G were in, then N would be out, and that would be okay. Sorry, I realized here's what I missed. And we normally don't redo videos when you make an oversight, because that happens in real life and doing games, and you have to go back and correct yourself. Because I was just thinking, wait a minute, I remember something else happening here. I forgot to put W out when I put F in. I put O in, but I forgot to put W out. You may have noticed that and caught me even in the process. Well, remember how we said V had to be out? Here's the problem. W is not an appetizer either. We can't have both V and W out because that would force all the appetizers to be in, violating the rule. So you remember what started that whole chain of logic? It was that F was in. All of these other inferences came from F being in, but that created an impossibility. So fascinating on this one, we learn right away that the star player can't ever be in on the game. That's pretty surprising. From here on out, we're going to put F in the out column, and F is an antibiotic. I think I might have said appetizer at one point earlier in the video. I'm thinking of a different game. You knew what I meant, I trust. F is an antibiotic, so it's going to go in that column, and it's always going to go in that space. All right, so now once F is out, we essentially have dealt with this rule, right? This rule is no longer prompted. It's no longer, the sufficient condition isn't happening. F is not in. So we need to go and think about the other rules, especially this one where V causes two others to be in. So supposing that V is going to be in will be very helpful to us. Let's put V in. That causes H. Notice I'm not using the dietary column yet until I get to M. That's our dietary. N and O are therefore out. Let's see who that leaves us. It leaves us G, U, and W. Well, if G is in, then one of these has to be out, but you know, that could result, but nothing is caused by N being out. So accordingly, we don't know that G is in. G might be in, and the rules could be consistently held, but we don't learn that. This rule isn't going to be prompted even if U is in, because N is not. And the only thing we know about W is that if it's in, F is out, and we already know that. So we actually can just put these out to the side, one side or the other as a, sorry, that should be a U, not a V. There are three remaining, but we truly have no idea which of these spaces they go in, G, U, or W. That terrible parenthesis is just going to bother me too much. It's not so easy to draw on here, but I did need to fix that. So that's the end of that viable game board. An important note about the decision tree process is that it's okay to have blank spaces. You don't have to fill everything in. You just have to have the framework that demonstrates what happens upon a certain condition. In this case, V being in. Remember, we learned F always has to be out. We suppose that V was in and we got everything that we could get because we used every rule. So we're actually going to go right away to just now putting V out. All right, now this is interesting. To fill out this game board, we're going to need to think about those D's a little bit more because we know that everybody else is in. And that can actually help us think about the D's more. What I mean by everybody else is in is that here's a dietary, here's a dietary, here's a dietary, but the out column is full with respect to the non-D's. Everyone else who is not labeled that way. That would be G and H, the antibiotics. It would also be U and W, the physical therapies. Because we have managed to fill up the out column, F, V, and remember, 2 dietaries, we can now fill up the in column with the non-dietaries, G, H, U, and W. And then we can look at this rule once more and say, all right, does that prompt anything? In this case, it actually does. G is in, so this rule is prompted, is forced as a sufficient condition. Either N or U has to be out. U is not out, therefore N must be. And the only thing we don't know about this scenario is whether M or O is the dietary regimen included. So very surprising about this game, not only is F always out, but by putting V in and then out, we've encountered everything we need to. We went through all the rules and we've got massive mastery of the game, even if G, U, and W are still to be placed in these last few spots. There are really only 2 basic frameworks that can occur in this game. If we use the decision tree process to put them out there in advance, we're in so much better shape. So this is a challenging game. In-out games are generally not easy. The intersection of conditional rules can be very challenging. We've got subcategories, but notice how putting in a lot of work on the front is going to give us that comprehensive knowledge that will allow us to move through the questions very quickly. There's one question in particular that would take so long if you didn't see what's always true here as an inference. I'll let you find that one, but it's a global question where you would just have to try example after example going through the choices if you didn't have these in advance. Doing these in advance saves you a ton of time on that question. So whether a game is simple or complicated, the decision tree method works powerfully either way. I hope you'll check out our other videos to see the range of simple to complicated and how the method is effective and can be learned and used to make you much faster and more reliable on logic games.